Section 2 of Chapter 6 is all about types of chemical bonds. So this first video in this section is going to talk specifically about covalent bonds. But a little bit of background information first. Atoms do not like to exist as independent particles in nature, meaning they don't like to be by themselves. Typically, they connect to other atoms, and they are held to other atoms by chemical bonds. So what is a chemical bond? A chemical bond is a mutual attraction, meaning both atoms are okay with this attraction. And this happens between the valence electrons in one atom. Remember, valence electrons are negatively charged in the outermost shell. And they attract to the protons, which are positive inside the nucleus, to another atom. So positive and negative are attracted, and this binds them together and forms a bond. Chemical bonding occurs, once again, because atoms are less stable by themselves. Chemical bonding, either losing electrons, gaining electrons, or sharing electrons, creates stability, and stability is what everything wants in nature. So first up is one of the main types of bonds, which is covalent bonds. And if you look at the picture here, you notice that these two lovely atoms are out to dinner, and what are they doing? They are sharing their food, in which case is represented by electrons. So a molecule, I will sometimes say instead of atom, okay, a molecule is a neutral, meaning no charge, group of atoms that are held together by covalent bonds. So I'm saying molecule, I'm talking about a group of covalently bonded atoms. So you can have two or more similar atoms or two or more different atoms. So similar atoms would be identical. So an hydrogen bonded to a hydrogen, or an oxygen bonded to an oxygen, like in this picture. You could also have different atoms bonding, like oxygen and hydrogen forming water, or carbon, hydrogen, and oxygen forming different types of sugars. So covalent bonds form by the sharing of electrons between atoms. So you'll see hydrogen, it's represented with a pink nucleus and one orbital and one electron. Remember, the number of electrons total is equal to the atomic number. So hydrogen only has one electron, and it just happens to be in its outermost shell. This hydrogen has the same. Most elements like an octet of 8. However, hydrogen likes 2. So this hydrogen will share, and it will get 2, and this hydrogen will share, and it will have 2 electrons. Everyone is happy. So what happens is the rings come close together, they overlap, and now they're going to figure 8 around each atom. So they're sharing those 2 electrons, and now they are happy and stable. There are 2 types of covalent bonds. You can have a polar covalent bond or a non-polar covalent bond. In a polar covalent bond, you're still sharing electrons because that's what a covalent bond is, but the sharing is unequal. This is because one element or one atom is bigger than the other. So I tell students to think of P, polar, and P, pooling. If you're pooling on the electrons, you are not sharing them equally. So one element or atom is going to be bigger, and therefore it has a stronger hold on the electrons. And this is also going to cause an unbalanced electrical charge. So if you look at the actual atom bonded, chlorine is represented by the blue circle, hydrogen is represented by the red circle, and they've overlapped to merge. They're bonded. Chlorine, as you can tell, is the bigger atom. So it is going to have the electron orbiting it longer than hydrogen. So this yellow electron is being shared, because chlorine has 7 and it wants 8, and hydrogen has 1 and it wants 2. So this yellow is going to orbit around chlorine, and then it will orbit around hydrogen, but that is much quicker because hydrogen is smaller. And then it orbits around chlorine and then quickly orbits around hydrogen. So chlorine has that electrical charge of the new electron, the negativity, a little bit longer than hydrogen. So it's that unbalanced electrical charge and unequal sharing. The water molecule is a polar covalent bond. The oxygen is bigger, so it's going to be pulling on the electrons from the hydrogens, causing it to be polar. You can also have non-polar covalent bonds in which the sharing is equal. So think of not pooling, NP, and non-polar. If you're not pooling, you're sharing equally. And this is because the atoms are similar in size. Because they're sharing the electrons equally, the charge that results is balanced. So for example, if you look at 2 chlorine atoms bonding, each has 7, and if they overlap, they'll share to become 8. So because of the same size, these shared electrons orbit at the same rate. So there's a balanced electrical charge from those new electrons being shared. So we're going to fast forward a little bit here. Drawing covalent bonds, you can either have a single, double, or triple covalent bond. A single bond is represented by 1 pair of electrons being shared. A pair is 2. So 2 electrons are being shared. So we say X because there's no element X. This can represent any element in a covalent bond. And there's 1 electron here and 1 electron here, and they form a line. 1 line equals 2 electrons. So you can represent it like this, or you could represent it like this. Or it could be represented like this. Sorry, my dots are not great. Okay, but this is the best format to use. So 2 dots is equal to 1 line. That is a single covalent bond. In a double covalent bond, 2 pairs of electrons are shared. So if 2 pairs of electrons are shared, there's 4 electrons. So we have 2 lines now. Each line represents 2 electrons. Once again, the X just represents any element that can be in a covalent bond. And then a triple bond is 3 pairs of electrons. So 6 total electrons. So we have 3 lines, each line representing 2 of the electrons. So that's something you need to know for the future. But since we're in the covalent chapter, it's important to kind of talk about it right now. Okay, and then just a quick video, because sometimes I think if you can actually visualize what I've said, it sticks a little bit better.
One or more atoms may share electrons, thus forming a covalent bond. Electrons will spend a portion of their time associated with each of the participating atoms. A single covalent bond represents the sharing of 1 pair of electrons, such as with 2 hydrogen atoms. A double covalent bond is formed by the sharing of 2 pairs of electrons. Atoms sharing 3 pairs of electrons form triple covalent bonds between them.
So you can see in all of these bondings, these covalent bonds, there's an overlap of outer orbitals, and then the electrons are orbiting in a shared fashion. They kind of figure 8 around. So that is a covalent bond. The sharing of electrons, you can either have polar or nonpolar, unequal sharing for polar, resulting in an unbalanced charge, and equal sharing in nonpolar, resulting in a balanced electrical charge.